Thank you everybody for being here in this meeting today, this little webinar that we are organizing here. I'm Pablo Moreno. I am collaborating with the PyCaret core team, specifically. I collaborate. I know everybody knows at this point in time that this is an open source initiative. PyCaret is an open source development based in Python. The creator is Moez Ali. I think that he's better known in the industry more than the Coca-Cola and many other super known brands, I believe, at least on the data side. And I am partnering with Moez. Hello. Oh, from Turkey. Hey, very nice. By the way, my condolences to Turkey for the recent earthquake and all the devastation that happens there. I'm very sorry for that. Anyway, continuing with the introduction, as I said, I'm collaborating I'm collaborating with PyCaret core team. I run their community administration, communications, and I collaborate with documentation. I also do some testing every time that PyCaret wants to do a new development, and the core team and the super smart people that we have in the core team are developing and fixing things. I normally go there and just try to just test it and see how it works and what are the issues and what can we improve, etc., etc. So in this occasion, we are with our great friends, Samantha Walker and Karambir Said. I don't know if I pronounced your name very correctly, Karam. My apologies if I didn't. Those friends are coming from MIA ML, which is a beautiful tool, application, solution. I don't know how to call it because you do many things. Which fortunately MIA and the team from MIA has been working intensively on how to connect and how to marry PyCaret. If we are into the machine learning space, we know what is this PyCaret all about. And I think that MIA is solving a great problem, not problem, but at least is providing a good value proposition to PyCaret, and of course, I'm sure that it will definitely will benefit everybody into the machine learning space and data analytics. So the agenda is going to be like, by the way, sorry, I talked too much. Samantha, Karambir, if you want to introduce yourself, for example, or if you want to say something, apologies. I'm a really bad host, apologies.
No, not at all, not at all. You did a great intro for us. Well, I'll just quickly say a few words and then we can get started. So I'm Samantha. I'm the co-founder and CEO of MIA, and we have Karambir on the call with us as well, who's one of our engineers. So one of the masterminds behind our product. And I mean, Pablo said it very well. Essentially, our goal, our vision with MIA is just to make machine learning more accessible to everyone. And we started off tackling that by making it easier to get models from code into production, into applications that people can really use, so that your projects aren't just stuck in your notebook somewhere. They're actually getting into the hands of people that can really use them. And so we're excited to be partnering with PyCaret on this and show everyone today how you can develop your model quickly and then get it deployed quickly as well.
Absolutely. Karambir, you want to say something? You want to introduce yourself maybe?
So hi everyone. As Sam already told you, I am Karam and I'm one of the engineers behind MIA. And I've been with MIA for more than a year now. I hope you guys would love what we have to show you today. So yeah.
I'm sure they will. And here is the thing. What I love about MIA, and especially this marriage with PyCaret, one of the biggest struggles that the developers and data scientists, machine learning engineers do have is actually putting models in production, because we have to invest a lot of time and effort analyzing data, creating the pipeline, modeling the pipeline, or modeling the data, creating a good model, evaluating the model, making sure that everything runs together. And that's a lot of time, effort, and talent that needs to be invested into a whole machine learning process. Once you get that done, Okay, as Samantha very well said, this is living in your desktop right now. So you have a beautiful model that has a great prediction capabilities, but so far it's still living in your desktop or your laptop or your system, whatever. How to make that model accessible to any other third party, your customer, your company, your employees, your managers, how to make it work in a scalable way. Okay, and well, there are packages out there. We got many packages out there: Streamlit, Flash. I mean, you name it, a bunch of packages out there. Gradio, even PyCaret has a couple of functions where you can create a fast API application that it creates an endpoint that you can call from a third party system, or you can actually create a very simple little web application using Gradio, which is okay. But we are missing a lot of things. We're missing what if I want to customize something in my web application? Well, and even not only just customize it, how to deploy it on large scale? Well, you need to start thinking not only on creating the app, also you have to think about infrastructure, web server, Docker, Kubernetes. Oh, we're talking big stuff now. So that's another type of animal. And this is exactly what MIA is solving, simplifying the whole thing behind a deployment on a large scale. And we're going to see a demo today on how to do it really fast and easy on how we like things up. So I'm going to start doing a very simple demo on two models. One is going to be a regression, and another one is going to be a classification. And we're going through the whole process. It's already pre-coded, and then I'll pass it on to you, and then you take it from there and surprise us. Okay. Okay, very good.
Sounds great.
Very good. So here is my collab where I already installed PyCaret, the latest version. Okay. So once PyCaret is installed, I'm going to start importing my basic libraries. Okay. So here what we're seeing is a simple or the usual concrete CSV dataset, which is all about cement, and the idea is to create a regression to predict the strength of the concrete given certain parameters or certain variables. Okay, we don't really care very much about what this is all about. Anyway, we can scale it. We don't need to do. We can scale it, of course, outside of or before the pre-processing. But we know that if we execute the setup in PyCaret, okay, if we execute the setup in PyCaret, we can actually normalize it, so we can scale it, and we can do also some other transformations into the pipeline on the settings once we import the regression model from PyCaret. So let's execute this very fast and easy. This is again with the version 3 of PyCaret. It does the partition. We're not going to change any partition right now. 70-30 is the standard, and that's it. Okay, let's run the compare model, possibly one of the most loved features in PyCaret. So we're comparing a bunch of models all at the same time against the same dataset and with the same parameters, which is very important. So in this case, we can see the scoring and the evaluation of all those models all at once and evaluate which one is the model that we like the most, whether if we are evaluating by area, by R-squared, by MAPI, or any other variable, or even all of them together. And it happens the extra tree regressor, okay, the extra tree regressor is the best model because it has all parameters more optimized compared to the rest of the models. Remember, we are predicting the variable strength, okay? And the variable strength, remember, is a continuous numeric variable. That's why it's a regression model. Anyway, let's create the model. Let's create the model in this. Once the model is being trained here, let's create the model using the acronym for extra tree, which is ET, okay? Using this function, and we are creating a model, as simple as that. So we create a model, okay? And the model is created. And of course, these values match these values, okay? Because we are using the same parameters all the way through. So let's make a prediction. What is making a prediction? This is something that I see very often on chats and LinkedIn's comments and everything. When we make a when we invoke predict model, and this is the variable of the model that we have created on the step before, what we're doing is applying the model to the remaining of the test data set. So we see the actual variable that we want to predict, and the new column with the prediction of the model. Okay, well, I'm not going to now plot the model and see the results of the residuals and everything. I'm not gonna. This is a demo. I'm not going into that model right now, into that process. But this is the residual, the remaining 309 rows for testing and validation of the results of the model. Once we are happy with the model, let's finalize it. So the model is finalized, means it's stored and it's packaged the model into the global environment. So now I store the finalized model into a variable called model final. I mean, we can call it any other way, but doesn't matter. Okay, fine. Now this is finalized. So here is the important part. What happens after I finalize the model? Well, I have to create a pipeline, and to create a pipeline, there is a function in PyCaret called save model. All I need is just two parameters. One, the variable that contains the model that I want to save, which is my previous variable that contains the finalization of the model. And how do I want to name the pipeline? Well, in this case, ET concrete regression regression 1. That's how I want to call it, or whatever the reason is. Anyway, I save it, and this is what happens. A new pipeline. So if you go to scikit-learn, there is a pipeline function into scikit-learn. So if you invoke it, you can actually see and visualize the pipeline itself. But this is the summary of the pipeline that has been created. So all the steps, it's a numerical imputer. All of this is coming from the settings indicated here on the setup. Okay, so everything you indicate here is going to be into the whole pipeline. So what are the variables that needs to be imputed? All of this is all the columns and everything. So this is a categorical imputer, transformer, blah blah blah, everything else. At the end of the day, what happened is that with this function save model, you generate a pickle file .pkl. Where is this file sitting right now? Well, this is a collab environment. If it was my own Jupyter notebook, my local notebook, it would be in my working directory. But this is not the case for in this environment where I'm using collab. So if I go here to my files, my folder files, it is exactly here. Okay, this is the pickle file. Okay, remember, this is a regression. I'm going to do the same thing for classification, and then I pass it on to you, because the key element here, this is also a little transformation that happens afterward, and this is something that we do for experimentation. Don't bother very much on this. It doesn't really matter. But this is the point. This is what we need. This is actually the pipeline, the model that we need to call or invoke later to make predictions, even outside of the environment. Okay, so let's move to a classification problem. Okay, here I didn't install yet PyCaret in this notebook, but this is going to take just a few seconds, I hope. In fact, I did it a while ago. We're using the 3.8, the RC8, but it doesn't matter. It's fully compatible with RC9, which is the one that we're using now, because we are continuously fixing and improving small details, but there is no conflict yet with RC8 and RC9, not for these purposes. Anyway, let's complete the installation of PyCaret in this environment, in this session. This is a classification problem, okay? So we were using a regression. Now we are going to do a classification problem. It's almost there. And in fact, I think, no, let's generate it so we can see. Okay. Okay, let's restart runtime. Yes. And this is all good to go. So let's import a data set for classification. In this case, it's going to be loanclients.csv. It's a data set that I took from Kaggle a while ago. I use it for demonstration purposes. What we have here is a bunch of features for customers in a financial services or credit in a company. And we have a target variable, in this case, target 0 and 1. What is interesting about this case, and this is why I selected on purpose, is because 0 means the customer is going to be non-approved or very high risk of giving a loan, and 1 means the customer is ready to be given a loan. Okay. So what is interesting is if we select the target variable, okay, the variable that we try to predict, this variable is very, very unbalanced. So we can see that almost 900 occurrences are on one category, and the one that we're trying to predict, okay, is just skewed to just one. It's a minority class. Okay, so if we don't do anything, okay, if we don't do anything, and we get a model that always is going to predict 0, we are going to have a model that it has, based on this, 89% accuracy. And I say, we may think, oh, that's nice. It's a model that is almost 90% accuracy. I have a good model. Well, but you are missing the good ones, the good customer that they are actually capable to have to receive a loan. Anyway, so let's continue. So here in the setup, in this scenario where it's very unbalanced, we can obviously normalize. I increase the train size from the standard 70-30 to 90-10. And of course, in addition to that, I also invoke the fixed imbalance. This is a multi application, a multi-process, a sample minority oversampling. Process into the setup that is going to be saved into the later pickle file. Anyway, let's compare the models. I'm not going to do it just to wait a few times because classification takes a little bit more of time. I'm going to directly create the model, which is again an extra classification model from the 3 families. Also, I'm going to create a model that we saw. It has a precision of 93.65%. and an accuracy of 97.22. Okay, so that means that because the accuracy is higher than the majority class proportion, the model is capable to predict also those customers that are good customers for let's see the model. Here it is, the confusion matrix. It was able to capture the true positives as well. So with minimum variance, which is very good. So this model is very decent. So again, I'm going to predict the model, and in a classification scenario, the model is going to give me the class predicted 0 or 1 because this target variable is treated as a category, not a number, a category. So it's going to give me the category predicted, whether if it's 0 and 1. And it's also going to give me the prediction score, or in other words, the probability associated with a specific category being predicted. So this is 90% probability that this customer is 0, 99% probability this customer is 0, and like that. Anyway, let's finalize the model. Again, finalize the model, just wrap it up and create the pipeline. And here, watch the pipeline. The pipeline, in this case, which is a classification because it requires more transformation that has been invoked on the setup, normalization, trend size, fixed imbalance, and all of that. This pipeline is a bit longer because we are adding more transformation processes, okay? Numerical imputer, blah, 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 and fixing and all of that. And this is our model, extra tree classifier, bootstrap, and all those parameters, which are the same as this, okay? Extra tree classifier, blah, blah, blah. All of that is here. Now, Where is this pickle? Again, if I was working in my local machine, it will be my working directory, but I am not in my local machine, in my local system, I'm in Collab. So if I go here to my folder, here is my pickle file, okay? So, Samantha, what should I do next?
Thanks, Pablo. So now that you have the models built, you're happy with them, and they've been saved to Pickle, you want to actually be able to turn them into an application that someone can use. So someone who's not necessarily technical, or even if they're technical, they don't want to have to open up their own, your notebook, get the right environment set up, run through all the cells like Pablo just did. They just want to be able to directly, access a link and start to use your model through an interface. So you're going to take those model files and you're going to come to MIA.
Okay.
So the website is mia-ml.com. Karam, can you share the link to MIA's homepage in the chat? And yeah, I saw Pablo's note there. Feel free to pop your questions in the chat, and we'll save time at the end for questions on both the model development and the deployment piece as well. So let me share my screen. I'll walk you through this. All right, so here I'm on, you can see my screen correctly, right? Yep.
Yes.
Perfect. So I'm on MIA's homepage now. So I'm going to log in to my account. And here, the first thing I see is my model summary page. So this is all of the different model files, or pickle files that Pablo was mentioning, that I've actually uploaded to my MIA account and are ready to be used, to be deployed and turned into applications. So I've already done for the concrete strength and loan application models that Pablo just built, but I will run through it again so that you can see what the steps are. So the first thing I'm going to do is I'm going to upload a model. And now here I have a choice to select the framework that my model is built in. So because we just built them in PyCaret, we're going to select that option here. And then we can select the version that we built it in as well. And Pablo mentioned it was the latest 3 RC8. So I'm going to select that here. Just a note on this, it's important that the framework and the version matches for us to be able to deploy the model into the right environments. There's a question here, Python versions mismatch. But well, let's I'll, like I said before, I'll get to all the questions at the end, just so we have time to go through everything. So here I'm going to drag and drop the pickle files that Pablo just created into here. So first I'll do the concrete strength one. So I'm just gonna grab that from my
the regression one. Okay.
Yeah, the regression, right? Concrete strength regression model. Okay, so I've added that here. Now, if ever, so this is a direct, model application. If ever I'm doing any kind of special pre or post processing of the data, or maybe I used other frameworks as well, I can upload additional files along with that pickle file of the model to be deployed along with the model itself. But in this case in particular, we didn't have anything extra to add here. So we don't need to use that option. And then finally, I can provide additional details of the models just so that I can keep everything organized when I'm uploading it to my account. So model name, I'll just put concrete for now, concrete regression, and this is version 1. And model description, predict concrete strength, and this is first version. Okay. And now I'm going to upload that to MIA. And sometimes it might take a bit longer, or it can be faster depending on the size of the model file itself.
Yeah. And also, as you're sharing your screen and everything, I mean, your system is using extra resources.
Yeah, true.
Yeah.
So now I see that the model's been uploaded, so I can go straight into creating an app for it. I can go back to my models page just to take a look at it. So I see here concrete regression, that's the one that I just uploaded now. I haven't deployed it into an app, so I don't see, it doesn't show that it's being deployed, but here I can see the model ID, description of the model and version I had, any files that I uploaded along with that model in particular. And from here, I can select this model file and create an app from it. So let's go through that together now. So now I'm into the edit app view. So this is our no code builder for creating the front end interface of your model. So you can personalize it by adding an image here if you want. You can provide a name to the app. So we'll say this is concrete strength predictor. Provide a description here if you like. This one's pretty self-explanatory. And then this is where we're going to, this blank canvas is where we're going to put the different inputs that essentially represent the features that were used to build your model. And so it's important that these are added into MIA in the same order in which you use to actually train your model, because essentially what our app is doing is it's going to take all those inputs and send them directly in that order as a prediction request to the deployed model to get a response back. So in this case, for this regression model, it's all numbers. So you have different options here on the left-hand side. You can use number elements, sliders, drop down or multiple choice for categories, and text box if you're dealing with NLP models or any strings as part of your inputs. So in this case, I'm going to use the number element. So I just drag and drop it onto the page. I can provide the field title. So for this particular model, the first one is cement. And I can put a description too here for any of the inputs. I can put, min and max limits if I want to, units if I want it to appear next to it here, and provide a scaling method as well. In this case, we don't have any of those options here, but description, I'll just put an example input amount, which is 276. And then I can keep dragging and dropping the different numbers onto the page here and fill it out this way. What I'm going to do instead, just to save on some time, we have an option, and especially this is useful if you do have a lot of inputs that are similar and might repeat themselves, where you can actually define it through our MIA JSON format, and the interface will automatically generate. So if I go here to show MIA JSON and scroll over to the right-hand side, you can see here in the sidebar here, this is essentially the JSON format that defines this entire interface. And so by following this, I can put as many inputs as I want and have this automatically generate based on the JSON. So I have a JSON already created for this application. Let me actually switch screens so you could see it here. So I'm going to share a different window. So here's the MIA JSON we created to define the front-end interface. So I can see the different elements here, number cements, and then another one for slag, and so on and so forth. So what I'm going to do is I'm going to copy all of this over. So I just copied it, and I'll go back to my other screen. All right, so here in this cell here, I'm going to paste the MIA JSON in, and we can see that now this has completely generated the front-end interface for this app, rather than continuing to drag and drop the different numbers onto the page.
Yeah.
So, and I can see here, yeah, go ahead, Pablo.
No, I was going to say, all you have used is just replicating the numbers option from the drag and drop menu, right?
Exactly.
Okay.
And then just
Okay.
changing the inputs. Of course, you can. I'm just using this for the sake of going faster in this demo, but you could also drag and drop the numbers onto the page and fill them out through
Of
the
course.
interface as
Yeah.
well. And you can move around inputs as needed, or delete these if there's an extra one you have that you don't need. So it's really a matter of preference.
Yeah. Yeah. Thank you.
And then in the prediction tab over here, so this is where we defined the type of response we expect to receive from the model itself. So either a regression or classification model. So we have both in this demo, so you get to see what both of those look like. For regression, essentially what the model is going to return is the number output from the prediction.
Strength.
And so yeah, exactly, the strength in this particular case. You have the option here to provide a prefix and a suffix to go before and after the number itself. So in this case, we added the predicted concrete strength is, and then you'll get the number response from the model. Then here, you can also see the model that is actually attached to this app. So in this case, it's the concrete regression model that we uploaded. You can see the description, the framework and framework version. And if ever you want to, let's say you reran the model, you got a better performance by adjusting some of the parameters, or you change the data set a bit and retrained the model, you want to swap out a different version, you can do that here. So you can click on change model and then select from the models and model versions that you've uploaded to MIA, the one that you actually want to be deployed into the application. So now that everything is built here, I'm going to go into preview mode. And this is where I can actually test out the app itself and see that it's working the way I expect it to be working before I actually deploy it and share it with anybody else. So here I'm going to put in some of these sample numbers here: 276, 116 for slag, 90 for ash, water 180. This is actually an interesting example for me personally because I studied civil engineering, so concrete strength is something that I'm very much aware of. So these are all basically different proportions of ingredients, and I believe age is probably the curing time. And then I can run a prediction here. Oh, I got a server just because I got logged out, so let me log back in. So here I can see, since I got kicked out, I want to go back to apps, and I can see here that because I hadn't made it published yet, this app is still in my drafts over here. So I'm going to go. I can still look at it here, but let me go back into edit it so I can finish it. So I'm back in the editor here. I'm going to go back to preview mode. And I'll type this in again. Nine, 870, 768, 28. Okay, this should work now. So we got the predicted concrete strength is 44.28. So now I'm ready to deploy this. So deploy now. And I can choose who can actually see and use the app. So whether it's private, public, or shared. If it's private, only I can see and use it. If it's public, anyone who has the link is able to use it, but you need to create an account on MIA for the moment to be able to actually access it. And then shared is when I'm building something that I want to share with specific people. So I can include their email address in here, and as long as they have a MIA account with that email address, they'll be able to actually see and use the app, either through the link that you share with them, or it'll appear on their apps page as well, which I'll show you in a second. So this one for now, I'm going to keep private, and I'll create this app. So now if I go back to my apps page, it's going to move away from my drafts. So you see I don't have any drafts here anymore. Here I can filter by all of my apps, or just my apps, or the ones that have been shared with me. So these are apps that other people created that shared with me. I'll go back to my apps, and I could scroll down to find the one I just built, which is here at the bottom. That's this guy right here. Another functionality I'm going to show you here is you see here there's batch prediction option. So
Mhm.
if I go to here, it basically switches the app view between running a single prediction and running a batch prediction. So this gives you the option. Let's say you have hundreds of thousands of lines of data that you want to run a prediction on the model with. You're not going to want to type that in one at a time and run predictions over and over again. So here you can upload a CSV file, which is, let me actually switch my screen over to show that CSV. So here I have a CSV file with the different headers at the top are the different inputs or input types. And then I have a few lines here of inputs with the different values for each data point essentially. So I'm going to go back to MIA. And here I'm going to upload a CSV file, the batch concrete. And now that's uploaded, so I can run a prediction on it. So I'm going to run this prediction, and that was fast. Prediction's already complete. So I'm going to download the CSV file now, and I'll open that and show you what it looks like. Let me share that screen with you. So here are my predictions. So I have the different inputs that were submitted to the model, and at the end, the final column of predictions, which is the results that actually came from the model as well.
Yeah. This is all done, so I don't have to worry about a web server, a compute system, storage system, a Git, a Docker, container, Kubernetes. Everything is done by me, in other words, right?
Exactly. So all of that, on the infrastructure side, what you need to set up to actually get that model itself deployed, hosted with an API endpoint, like Pablo mentioned, spinning into a Docker container, having Kubernetes set up so that you can scale up and down resources as needed. All of that happens on Mia's end behind the scenes. So all you need to do is provide that model file, click a button, and the whole process is automated, which is something that typically could take, like if you know what you're doing, could take a week to set up.
If you're lucky.
If you're lucky, if you're really good senior developer and you know what you're doing.
Yeah.
If not, could take months. And so when you're just trying to, get something quickly into the hands of other people, then it's much easier to use a tool like MIA to go through that. And then that's only on the model hosting side, let alone needing to put together a front-end application for interface for the model itself, which is involves full stack work, right, on both the front-end side, the UI UX side, and also the back-end side as well.
Can you show us?
Comes automated. Yeah,
absolutely. Can you show us the classification final app, just in case, because I mean the intermediate process of building the process is literally the same, right?
Exactly. The only difference, and I'll show you quickly. I'll just go into, it's an app I had already created. So I'm going to go to that one, and I'll just edit it to so you can see the only difference. So here we use some slider elements instead of the number elements, so you can see what that looks like. And then we have units added to each of these as well. And then there's also things like, here there's a multiple choice option. So you can select the encoding method that you use, so you know how to translate the selection into a number for the model. Education comes as a string, and so there's a text box here that you can use to input the right string there, and then a few more multiple choice options and sliders. And the main difference here is in the prediction itself. So here, the model type is classification. And then the classification type is binary. So you only get, there's two options essentially that you're going to get from the model. You could also, if you're building something that returns that has multiple classes, you could specify that too. And then you can select either the output as a probability or a label. In this case, we went with label because it's either 1 or 0. And then we added this prefix and suffix here. So if I go back to that app, let me open it here. I can input in different options. So I'll use the example options here. Credit amount 201,000. Credit term is 16. Age, let's put 54. We can see the slider is moving around here too. Female, let's put higher as an option. Product type, having children, no. Region 7. Income, family status, phone operator, is a client, yes, and then let's run a prediction. And similarly, so here the result is 1, meaning that that loan application was accepted. Similarly, you can run the batch prediction on this as well, that nothing changes between the other example and this one. And Pablo can actually pop the links in the chat. We have these apps set up as public apps, so you can access them yourself and test them out and get familiar with how it works. Beyond that, I'm going to wrap this up soon so we could go to questions, but we have a tutorial section on MIA, and maybe Pablo, we can turn this webinar into a tutorial for people as well. And we also have docs here that I'll click on this and share this tab. That basically outline, kind of walk you through all of this different steps that we just went through in MIA and more. And if ever you do want to, in addition to having the front end interface for the app, if you want to be able to run, just have an API endpoint that you can, for your model that you can hit for predictions, that's possible through MIA as well. And you can read up on how to do that in our docs, section 6, 7, and 8.
Yeah, I am looking for the links and I will share in a minute. Okay, we have, it was an amazing demo. I believe the audience enjoyed what you presented. And of course, I don't know about the audience, but 90% of my deployments are via using MIA with myself, my own organization, my own company, as well as other customers where I train how to do it. So because it saves me a lot of time, and of course it kills a lot of pain in order to develop and everything. And at the end of the day, time is money, and we need to deploy fast, analyze, and when you deploy fast, you analyze faster, which is exactly what we need. So we have a couple of questions here that I prefer you to handle. So for the first question, it says Bugra, I believe. Sorry if I didn't pronounce properly the name, Bugra. Sometimes Python version mismatch when in PyCaret model development and loading the models from development in production. Maybe MIA solves this problem, the mismatches on the Python versions.
Yeah, Karim, did you want to answer that one?
Yeah, so basically Bugra MIA, as Sam showed you before, like the custom scripts and everything. So if you would have noticed, there's a requirements file in there as well. So in case like there is a model mismatch, on with the default settings on MIA, or like a version mismatch between your training version and the deployment site, you can always use a custom requirements file to like set up the environment just the way you want it to be. And yeah, that's and we are actually going through right now, we're going through a major infrastructural change as well, which will ease up this process of setting up different environments even more.
Mm-hmm. Yeah, it's one of the things that I personally like about MIA, that it's not locked. So I can, if I have an extra requirement where if in a specific version of a package or something, I can actually upload my own requirements to the application and customize the application according to my requirements, which is very cool. So it's not like a prefix no code box where you don't have much flexibility. So second question, also from Bugra, for the batch predictions scoring in corporates like finance, Kubernetes, container environments, every time we face memory errors, insufficient CPU, etc., MIA ML backend is capable of solving this kind of problem, or is this on your to-do agenda?
So I will let Sam also like add on to this later, but so currently Mia basically scales with demand. So it does, it is able to handle like big loads, but we also have like file size limits on uploads, which can be like a limit on the CSV file size or limit on the model file size. And those are some things we can like as I told you before, we are going through an infrastructural change, so we are exploring options as to what would be the best way of supporting like large files and stuff like that. But yeah, that's where we are.
Perfect. Hossein is actually making this question. This question may seem irrelevant to this session, but Hussein says that he has problem tuning a model in PyCaret, which has caused me to raise a question in Git. Now one answer. So the tuning model does not treat by MIA. Am I right? So, well, you can answer, but I believe that if it's a tune model, it has to be refreshed on the PKL file. And the PKL file is the one that is bringing the latest version of or the refresh model. Am I correct, guys? So
yeah, for at this point in time, yes. Definitely the ability to be able to continue to iterate on the model and have that more seamless into me is something that is part of our pipeline. But for now, at the moment, yeah, you need to update the pickle file itself, so you can upload a new pickle file which represents a new version of the model when you have it tuned to your needs, basically.
absolutely.
Something else you can, depending on how behind the scenes you want to get, because everything that we showed you today through the interface is possible through the API as well. You could set it up so that as you're tuning the model and you have you could automate that process basically. So once you have a new version, that through the API can get sent directly to MIA, the model can get updated in the app. So it is possible to kind of do that behind the scenes through the API, and in the future we're working on making that more seamless through the interface as well.
Absolutely. Okay, more questions are coming, guys, so be prepared. Okay, so
that's great. We love it.
Yeah, question from Brandon. What are the costs involved with MIA?
Yeah, so that's something, it really depends. Right now you can sign up to MIA today for free and do get a free trial automatically, basically. So if you want to test out the apps, Pablo sent the link in the chat. You can do it that way for free to start. And then in terms of the cost, it really depends on what, because it's all based on the models, like the number of models and how big they are and how much they're being used. It really just depends on the specific needs of the individual or the organization. So Brandon, I'm happy to follow up with you after this to discuss in more detail, so we can see what might make sense for you and for your company.
Absolutely. I will provide the LinkedIn's, your LinkedIn's into the meetup chat. Somebody wants to connect with you privately and whatever discussion comes up. Okay, another question from IGS says, are events safe? For example, an user is using the app and introduces inputs and uses the prediction. Can we get that data as a way to record new data inputs?
So the answer is not yet, but that is also part of our roadmap as well. So essentially be able to have a log of what you sent and what the results that you got back. can be an important way to to track the model performance as well. So that it's not possible in MIA yet, but we're working on it for the future.
Okay,
yeah, go ahead.
I'd like to add to this, Sam, that MIA backend does support logging, but currently it's not available as a user available feature. So like it is in the pipeline.
Okay, thank you. Okay, so
perfect.
Yes, I guess.
Yeah, no, I was just thinking. Thank you.
Good, very good, no problem. You can connect obviously with Samantha and Karam for any further questions that you may need. Okay, we have a few more minutes and few more questions. Okay, Ugo Chukyu, I think I pronounced it correctly. If I don't, well, apologies for that. It says beautiful presentation. I have a couple of questions. Okay, would this be a replacement for a Streamlit?
Yeah, so let me answer them one at a time. So it could be, yes. The big difference between Streamlit versus MIA is like MIA is it can be completely no code. So you don't actually need to learn a different framework to get your model into an app. And the model can be deployed separately from the app as well, and have you can send requests to your model through our API endpoint. So it's in the similar, it's a product in a similar space. The big difference just being that MIA is faster and easier to use, basically.
Absolutely. For CI/CD purposes, does MIA allow to use GitHub like Streamlit, or do we have to upload NeoPickle model files every time?
Yeah, so for the moment, you need to upload the pickle files every time, unless you're working into your workflow through our API. That's a possibility as well. But as we're expanding the product, like I was mentioning before, we're working on making that whole process more more streamlined, more seamless as well, and integrations with things like GitHub and other tools you might be using as part of the roadmap.
The same person actually asked if MIA has a REST API which can be used for inference.
Yes. So everything that you saw me do today, and essentially everything you can do on MIA can be done through the API interface as well. And that's all. We didn't have a chance to go through it on this webinar. Maybe we could set up a future one to cover that as well. But
sure.
You can follow that through in our docs, which is linked to from the MIA homepage.
Fantastic. And I believe this is the last question for the session because I don't see any more here. Hossein actually asked the shape of the file for prediction, like delimiter, header, etc., should necessarily be similar to the one that was used when training the model before?
Yes, I actually answered that in the chat as well.
Okay.
For now, yeah, that whatever data shape and whatever data columns have been used for training, it is better to use like at least like you can change the column names so that they don't look like variables, but the order of inputs and the shape of a CSV should be the same.
Excellent. Okay, I think that I don't see any more questions. I think we are covered. Great session. Thank you. Okay, guys, I believe that this is the end of the session. As I said at the beginning, we are going to share the recording with the rest of the audience via Meetup. We will also share it at the Slack page of PyCaret, as well as the channel of PyCaret in YouTube. So your session and your demo is going to be available to all PyCaret users. So Octavio is actually congratulating. You're thanking, oh man, so thanks for some millions. Thanks a lot. Yes, people like it. People like it. So I knew that they will like it because I like it. So I knew. Anyway, thank you very much for your time here, your presence, your fantastic product. And well, now we can build and deploy a machine learning model literally in less than 1 day, which is just Jesus Christ. When we could do this, so I don't know. So, but thanks, thanks for the project.
You can probably do it in a matter of minutes.
In a matter of minutes, yeah, that's right. Yeah, it is. That's true. Okay. Again, thank you, Samantha Karamber. So we'll be in touch, and we'll see you later.
Thanks, everyone. Thanks a
Thank-
lot. Thanks, Pablo.
Thank you to the audience
Thank
for
you very
being here.
much.
Thank you.
Thanks.
See you soon.
Thanks, guys.
Bye.
Bye.
Bye.